Oh, welcome, Ji. Let us start. Today, I am going to discuss on the bridge design patterns. Okay, so bridge pattern is a kind of a software design pattern, and this again we will discuss in a two part. First, about the theory, what design patterns is, and second, we are going to implement this design pattern in a Java as a code language. So let us theory is very simple. Okay, so this design pattern say is used to decouple an abstraction from its implementation, so that these two can vary independently. Simple. This is the kind of a bridge, means they are just decoupling. They say कि your abstraction and implementation should be decoupled. Abstractions, maybe this is the one abstractions and abstraction, and have a list of implementation, list of implementation. Okay, so abstraction have a list of implementation. So in this case, let's say this is the client. This is a client have and abstraction object and maybe interface or abstract classes, and lots direct list of implementation classes might be. So here our client code is directly coupled with your implementation. So abstractions and uh, coupled with the implementation. So this design pattern say somehow this should be decoupled so that it can be changed, this can be changed, and this can be changed. So how will decouple somehow? Somehow instead of client we have to write between somewhere some let's say abstract class that is they depend upon this and they depend upon this. Okay, so that now this abstraction and actual implementation now can be independent and they can be changed. Different implementation can be changed, different abstraction can be applied somehow. So here say abstraction. Abstraction simply means you're trying to say maybe your interface are abstract classes and they have a list of implementation, but generally they are tightly coupled. So how will make a decouple? For decoupling, we have to put between something else. So here something kind of abstract class you can put between the actual user, the client, and actual implementation. So let us look the example. Okay, so let us take an example like let's playing online game. Okay, so generally maybe client uh, your client can play game. Maybe we have a cricket game, maybe football, maybe tennis, any kind of game. So generally, these might be nowadays these maybe platform, on which platform you are playing this game. Maybe cricket you are playing on a window machine or Mac machine or maybe Linux machine. So here your online games playing and your Windows generally have a dependency. And client, if client want to play game, let's window game, so they kind of need some window OS on which they can play game. If want to play a Mac game, need a kind of OS, Mac OS, where they can play game. So here your actual implementation may be cricket, maybe football, maybe tennis, are independent with the clients. So this is the abstraction layer between that. The game is played on maybe which OS? This is maybe Windows OS, Mac OS, or somewhere else. Implementation can be game, maybe cricket game, football game, tennis game, any kind of games. So the here we are just making a decouple between the actual uh, game with the client. So let us write the same example. So let us we have a kind of a class that client that the client can just should be one method like a play game. Okay, so somehow which game they are playing, there should be kind of one game. Okay, so let us there would be some kind of a class game, and like game. What about let's game have a one method like a void play. That's the game. Okay, and this from this game object just use a play. So here let's mark as a abstract so that key each you can say this should be marked as abstract. Okay, that means key the game can be cricket, or maybe you can say tennis or football. These are the game. So actual class can implement this game, but the problem on which OS they are playing, so might be different kind of OS. So let us we have a kind of a interface like a game OS, and let's we have a only method like start. Okay, and let's key our maybe Windows implementation like Window OS implements your game OS. I just overwrite. Okay, s out on Windows OS. Okay, so kind of one implementation. Maybe let's another one more implementation like Mac OS. Mac OS means on which OS the game is playing. So each game is depend upon the OS. Maybe cricket or some let's key. So in anyhow we have a let's like game OS, and right let us initialize. Okay, now so let's key we have again now game, maybe we have a one game like class cricket, and just extend your game, and they have to okay, and also override here play s out. Let's key uh, play playing game is playing. Okay, cricket is playing. Okay, game. Before yeah, before starting your cricket game, you have to somewhere your OS started on which you are playing a game. Okay, let's this is the kind of one more implementation. Let's say football. Football, just football is playing a particular OS. So now your client is just uh, play any game, but they are not tightly coupled with they are playing with the OS or which OS. They are generally just play game. Whenever you are playing cricket game, cricket say I want to play on particular specific OS or particular whatever football on which OS. So let us just here let's key insert one setter so that key. Okay, so let us client client. Okay, now client just want to set to game uh, a new let's cricket want to place. So now cricket is let's keep play on the macOS. Now simply client just play. So here you are your client is depend upon game only, not in which OS they are playing. OS is decided by the game on which operating system they are going to play. So client is independent with the OS. OS is decided by your play. Maybe you want to play different game. I want to play football. So you can play. So in this way, uh, different kind of your client can play a game, but they are not directly bound to the which operating system they are playing. They are decoupled client. This client is very decoupled. Client generally only know, okay, I want to play game. Game maybe play on the different OS. One, let's see, one customer playing on the window, different customer playing on the maybe Linux machine. Or in future, let us see one new OS you want to introduce. So here your client code is actually decoupled. His let's key you want to introduce your game can be play on the Linux machine. So here client is decoupled. Any implementation can change. So here your new OS come. Just you go and implement one new OS. Let's key Linux OS. So here just only change only one class. Linux OS. Now your client and abstraction doesn't change anything. Now you can play any game. Now I want to play game on the Linux machine, Linux OS. So your implementation is decoupled with the client. Your client code is nothing changed. Client now can play on a game on Windows or any OS. Or client even can play different game. Let's give here we are playing a football, cricket. Let's have one new game come, tennis. So you are just only is just make a subclass one new game like a tennis. Now your client code is decoupled. There is no any change in your abstraction. I mean even your client code. Now client can play different game. Client can play. Let's say I want to play tennis. Tennis. Maybe I want to play on the window machine. Window machine. So this bridge design pattern just help your implementation are decoupled with the actual abstraction. This is the client is abstraction. Client know this is the game I want to play. If you want to here implementation can change. Currently you are playing game only cricket on the window machine, but now you can play tennis on the window machine. Your client is independent. Your implementation can be varied. So this design patterns are just kind of one suggestions whenever you are implementing abstraction and implementation, try both should be decoupled. If someone can change, yes, anyone maybe here game can change or OS can change, both are decoupled and client doesn't worry. Okay, so hope it's clear. how we have implemented. Your client is only depend upon the abstraction. Game is abstraction. Abstraction here are say game is going to play, but this is not dependent on which OS and which game. According to implementation, let's someone implemented the cricket just playing on the different OS, or football playing on different OS. OS can here they're not depend upon any specific OS. OS can be changed. Maybe Linux OS, maybe Windows OS, maybe another OS come. So any new implementation can change without affecting your abstraction and without affecting your client code. Now this your abstraction never need to change. Implementation can vary. You can introduce new OS, you can introduce new game, but this is the independent. The same here definition say your abstraction should be decoupled from its implementation. Implementation and both can be vary. Here we have to change our abstraction depend upon the game. But game which game doesn't vary. Any game implementation can be changed. Which OS can be changed. So if again just a review the way we are implementing the bridge design pattern. Bridge design pattern say कि abstraction and implementation should be decoupled. Here our abstraction and here the list of implementation. Maybe OS implementation or even the cricket game implementation. Different implementation can change, but our abstraction and our client never need to change. Now its client code is very independent. Client just I want to play game on this OS, this game. Any implementation you can come. So this way we have implemented our bridge design pattern. We have created, this is the client which want to play game. This is the setup game, maybe cricket, maybe football. Okay, on which OS, maybe depend upon which OS, and both are dependent. This is the abstraction. Now abstraction game OS are playing game. They are completely independent with the implementation. Which OS they are playing doesn't vary. Which game they are playing doesn't vary. Can be anything. A textual client can play any game on any OS. So hope it's uh, makes sense for you whenever you are implementing some abstraction and some implementation. If feasible, try to make both are decoupled so that you can inherited getting the benefit of the bridge design pattern. This design pattern help us. Your implementation can be changed. Your abstraction can be changed. Both are the independent. So this is the basic principle. Whenever you are writing any kind of application or code, try to make as possible your component, your client, your abstraction, your implementation should be decoupled. Okay, so that's your bridge design pattern. Bridge design pattern just make a bridge, help abstraction and implementation should exist, but they are not tightly coupled. They should be independent so that anyone implement any implementation can change, any abstraction can change. Here abstraction or OS, which OS you are playing game doesn't matter. Which game are playing on which OS doesn't matter. But both can play. Client is just no, I want to play this game on this OS. Okay, so hope it's help for you to get the understanding about the bridge design pattern. And if you want to make a more feel comfortable about this design pattern, any kind of take an example and just write this code, your abstraction and your implementation, try to make a decoupling between that, and now after that you feel something better on the bridge design pattern. So hope it's help for you. And again in the last, again I would like to say thank you for watching this video.